Welcome to Geometry. It's Coordinate Geometry 3, CG3 notes, and this will cover the composition of transformations on the coordinate plane, starting with example A. So a triangle ABC, and I went ahead and drew coordinate axes here, x, y, and we'll just assume every tick mark is 1. So A is at -1, 0. This is point A. And then point B is at 1, 2, 3, 4, 0. Here's point B. And C is 2, 1, 2, 3, 4, 5, 6. So here's C. Oh, just C. Okay, there's C. And I'll go ahead and connect the vertices of the triangle. And the last side's along the x-axis. So there is your original. Now the first thing we'll notice is that it's translated by the rule xy leads to x minus 6, y minus 5. So every point is going to go to the left 6. So the left 6 and then down 5. So left 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and that will be A prime. And then left 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, B prime. And left 6. And then finally C prime. And there is the image of triangle ABC. Okay, and it says then it is going to be moved or translated by x plus 14, y plus 3. So this is to the right 14 and then up 3. Okay, so the right 14, that's a lot to count. So I'm going to start with A. 1, 2, 3, 4, 5, 6, 7, and then so that's 14, A double prime. And I know that B is 1, 2, 3, 4, 5 to the right of that. That's a little bit faster than counting it. And then I know that C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then up 3. I was wondering, I forgot to go up 3, didn't I? There we go. So there's A double prime, 1, 2, 3, 4, 5. There's B double prime, and then there's C double prime. So right 14, up 3, and let's go ahead and connect the vertices again. And there's the second one. So then it wants us to answer a couple questions below. So what is the single translation, or what single translation? Looks like I got a little bit of a spelling here. Translation is equivalent to the composition of these two translations. So let's see here. So, in other words, what translation is going to go from C to C prime? Well, let's go ahead and do that. So C, the coordinates of C is 2, 6, and the coordinates of C double prime is what? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So x is 10 and y is 1, 2, 3, 4. Okay, so it looks like what I'm doing is going x plus 8, 2 to 10 is 8, and then y minus 2. So down from 6 to 4 would be y minus 2. You also sometimes see it like just as 8 minus 2, and that's going to be the equivalent. The equivalent as x plus 8, y minus 2. Okay, so there's that single one. Now, what single translation brings the second image a double prime, b double prime, c double prime back to ABC? So in other words, how do I go from here to here? Well, from 10 to 2, I'm actually just going to subtract 8, and then 4 to 6, I'm just going to add 2 to y. Or we could write it like this. Okay. So there we go. So that's how we do it. It's interesting to note that there's actually another way to do it. That you notice how it was x plus 6, x minus 6, x plus 14. If I go minus 6 plus 14, I get 8. Just like I did right here. And then if I go minus 5 plus 3, I get minus 2. So rather than doing it this way, we could just add these together to get one rule. So in other words, this is the same thing as x minus 6 plus 14, and then y minus 5 plus 3 will also get you x plus 8, y minus 2. Okay. Well, that's example A. So when you apply one transformation to a figure and then apply another transformation to its image, the resulting transformation is called a composition. In other words, you're doing multiple transformations, which is what we did in the previous example. So the key word's composition. Example B, given triangle PQR with vertices PQR, reflect it across the y-axis to create the image, and then reflect that image across the line y equals 1 to create P double prime, Q double prime, R double prime. Okay, so if you reflect it across the y-axis, then the distance is going to be the same. So 3, 1, 2, 3, it's Q prime. And then R would be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, R prime, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, P prime. Okay, so there's the reflection across the y-axis. And then I want to reflect it across the line y equals 1, which is this line right here. So the line y equals 1, reflected across there. So it's 2 away, so it'd be 2 away there. So there's P double prime, and then it's 1, 2, 3, 4 away. So 1, 2, 3, 4. There's R double prime, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So Q double prime, and now I have the second image. Okay. So let's see what we have here. Some questions here. What is the transformation rule that reflects PQR to P prime, Q prime, R prime? Well, it looks like the y value is staying the same and the x value is changing sign. So -3 becomes +3, and for r, -6 becomes +6, -5 becomes +5. So the x value is changing sign and the y value stays the same. And I'm going to skip down to D real quick too. It says, what's the transformation rule? So that to go from its image to the second image, so from P prime, Q prime, R prime to P double prime, Q double prime, R double prime. So let's see what's happening there. This is a little bit, well, P prime, the coordinates of that is x is 5, y is 3, and P double prime, the coordinate is x is still 5, and y is -1. And so this is going to be a little bit more complicated because it is the line y equals -1. So, all right, let's go back to B then. What are the coordinates of the vertices P prime, Q prime, R prime? So P prime is 5, 3. R prime, I'll go in order here. Q prime is equal to 3, 6. R prime is 6, 5. Okay. Now P double prime is 5 - 1. Q double prime is 3, 1, 2, 3, 4, -4. And R double prime is still 6, and this is going to be -3. Okay, so based on that, what is the rule? Well, it looks like x is staying exactly the same. So x does not change. So what happens to y? Well, it switches signs. It also goes, so if we switch this to -3, we'd have to add 2 to get to -1. If we switch this to -6, we would add 2 to get to -4. And if we switch this to -5, we'd add 2 to get -3. So it's kind of not enough room here. So -y plus 2 is what will go in that box there. So let me write it right here. So x comma -y plus 2 is the rule. So is there a single rule that goes from PQR to P double prime, Q double prime, R double prime? Well, let's see. So P is -5, 3. Q is -3, 6. R is -6, 5. P double prime is 5, -1. Q double prime is 3, -4. R double prime is 6 - 3. So what's happening to the x value? Well, the x value is just changing sign. That's simple enough. So -x. And let's see. What's happening to the y? Well, it looks to me like it is also changing sign. And let's see. If we were to change that to -3, we would add 2, -3, add 2. So negative x and then negative y plus 2. So I'll write that a little bit bigger here. So negative x, negative y plus 2. That's your transformation rule. And it looks like we're really just combining these two together, because this x is staying the same. So the minus x, if you put that right here, you have that rule. Okay. That's example B. Finally, one more, example 3. I think you should bear with me. I know these notes are a little bit longer than usual. So if you need to take a break real quick, you definitely can, but there is more to do here. Example C. So given triangle DEF with vertices D, E, and F, reflect DEF across the line y equals x to create D prime, E prime, F prime, and then reflect triangle DEF 90 degrees clockwise about the origin to create D double prime, E double prime, F double prime, and then reflect that across the x-axis to create another one there. Okay. So first of all, let's reflect it across the line y equals x. And to do that, I'm going to draw that. So the line y equals x is where the x and the y values are the same. So if I just put a line right here, this is the line y equals x. And so we actually do have a rule for that we discovered in the last CG lesson. Which I'll show you real quick. So here's your ordered pair rules, and this is going to just switch the x and the y, and you get your reflection across the line y equals x. So what we'll do now is go back here and just switch the coordinates. So E prime, D prime, F prime will just involve switching these. Okay, and the coordinates of the vertices I wrote right here, so that answers B. And then what about the coordinates of the next one? Well, let's see here. The next one is reflecting. Now this is kind of interesting. They want you to reflect this 90 degrees clockwise. So we're not doing the image here. What I mean by that is here's your figure, and we're going to reflect, move it, let's see, 90 degrees clockwise, so this direction, until we get right about here. 90 degrees clockwise rotation. We also have a rule for that, and let's see what we did. 90 degrees clockwise would be y comma minus x. Y comma minus x is the rule we have for that. So that's going to give us, let's see, first I'm going to switch the order here. you switch the x and the y and then change the sign of whatever is in the y location. And that's the coordinates that we get. So let's see if that works. So here's d double prime, e double prime, oh, oops. Hold on. I'm supposed to do this to the original points. Okay, let's try that again. 2 comma minus 4, 0 comma minus 1, and then 6 comma 0. So what I'll do now is change the sign here. That's positive. And so now you're at 2, 4. And that would be d double prime. F is 6, 0. Oh, that's the same. So this is actually the same location. That could also be F double prime. And then E is double prime is right here. So let's see if that makes sense. Yep. Looks like that's exactly where it should be. Great. Except, yep, we got it. Good. Okay. So there's your triangle rotated 90 degrees clockwise. All right, and then we need to do it one more time where we rotate it about the origin to create, or we reflect it across the x-axis. So reflect this across the x-axis, and it looks like we go right here, don't we? We go from here to here. Oh, so these coordinates are actually going to be the same as that. So 2 minus 4, 0 minus 1, 6, 0. Nice. So d double prime, e double prime, f double prime. So what transformation rule goes from this to this? Well, that's where you, it's like the x coordinate staying the same and the y coordinate changes sign. So what single transformation rule takes you from this to this? Well, it's actually the same as the first one up here, as yx. Okay, so look at that. Switch that and we can see that that would make sense because first you switch, then you change the sign, so that would change that back to positive. So all you're doing is switching the x and the y. Okay, so to review, trying to show you here that a reflection across the line y equals x is the same thing as a 90 degrees clockwise rotation about the origin and then a reflection across the x-axis. They're equivalent. Whew, okay, there we go. Finally, we have an extra example and then a closing question. And this I'm gonna have you do in class on your own. So do in class on your own. So right now you can go ahead and stop. This is enough for the homework. 25 minutes is definitely enough. So if you do up to here, you'll get full credit on the notes. And then I'll have you guys do the closing question also in class as well. So the stop sign, I'm actually making an executive decision and moving it up here. Okay. Now, so you can go ahead and stop. Unless, of course, you're absent, then you will need to do this on your own. And I'll go ahead and show you real quick how that would work. Okay, so draw any triangle CQR. So I'll just draw a random triangle. C, Q, R. C, Q, R. And x minus 4, y plus 1, that's to the left 4, down 1. So 1, 2, 3, 4, down 1. So C prime, 1, 2, 3, 4. R prime, 1, 2, 3, 4. Q prime. So there's the image. And then we'll do a reflected across the x-axis. So here's your x and your y-axis. So I'll put those right there, just to be clear. So reflection across the x-axis would put this right here, this right here, and this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Whew. Okay. So there's that. And what single transformation rule makes it? Well, first of all, here's your first one. And your second one, a reflection across the x-axis, would change the y value. So if you need to move it, let's see, what I think we would do is this would be x minus 4 still, and this would just be minus y plus 1. Right? So just a little algebra review. If we have minus y plus 1 with the parentheses around it, that's the same thing as minus y minus 1. Because the distributive properties as a negative will apply to both of these. So your final rule would be x minus 4 minus y minus 1. Now let's make sure this works. So if I start with R, well, let's do Q actually. Start with Q. Q is 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. And then Q double prime is negative 1, 1, 2, 3, 4, 5. Okay, so let's see. X minus 4, yep. 3 minus 4 is minus 1, that's good. If you put 6 in, you actually get minus 7. So it looks like this should be plus 1, so we made a little mistake there. Okay. So all we're going to change then is make it negative y plus 1. So that was wrong. Great. Okay. Yeah, so I guess the negative y will plug into that, so that wouldn't apply. Good to know. Okay. Well, there's that. And then name a single translation vector for these three. And to review, if you have a translation vector 2, 3, that's the same thing as x plus 2, y plus 3, right? And so if you just add these together, 2 minus 5 plus 13, so 2 minus 5 plus 13, and then 3 plus 7 plus 0, that will be 10. And then this would be negative, that would be also be 10. And so this would be your result. Whew, okay. Well, that concludes the notes for CG3. Thank you for listening.